Hey kids, welcome to a fun physics lesson. So, you might think that stars look exactly like this, right? Well, this isn't the case. There's a lot more to how stars look that you might not know. Plus, did you know that there also exist different types of stars? It's true. We'll talk about this and a whole lot more, as well as how the universe was created, in this video. First, let's see how a star is born. It all starts with a big cloud of gas and dust in space called a stellar nebula. Gravity causes the dust to come together to form stars. If enough mass comes together, fusion will begin at its center and a red dwarf will form, which is a star made up of small main sequence stars, which fuse light elements. How long will this red dwarf survive? Unless it eventually runs out of hydrogen to fuse into helium. It will start dying and turn into a white dwarf, a star that does not fuse any elements but will keep radiating heat until it turns into a black dwarf. You wake up in the morning and look towards our own sun and wonder, what kind of star is this? Our sun is a medium main sequence star that started its life by fusing hydrogen into helium and has been doing so even today. In the future, it will start fusing helium into carbon, which will cause it to heat up into a red giant. It lives up to its name as a red star, but it is also old and hot. Red giants will only survive for 1,000,000 years before most of their hydrogen mass drifts off into space, which causes them to die off. The mass that drifted off is called a planetary nebula, and eventually when it is dead, it becomes a white dwarf. We keep hearing about fusion when we learn about the life cycle of stars. Now let's go in depth and see what happens during a fusion process. First, let's understand what the word means. Fusion is a process that powers the sun and stars. It is a reaction in which two atoms of hydrogen combine or fuse to make an atom of helium. During the process, some of the mass of the hydrogen is converted into energy. So how does fusion happen? Well, to make fusion happen, the atoms of energy must be heated to a very high temperature, 100 million degrees, so that they are ionized and have sufficient energy to fuse and be held together for a long time. The sun and the stars do this through gravity. This leads to a supernova. So far, we've learned about the different types of stars that make up the galaxies, as well as the process of nuclear fusion. Now let's learn about the event that started the creation of our universe, the Big Bang. No, not that Big Bang. We're talking about the theory that scientists came up with that states that the creation of the universe was caused by a singularity that expanded and formed everything that makes it up, such as energy, matter, and galaxies. 3 pieces of evidence support the Big Bang theory for the origin of the universe: redshift, cosmic microwave background radiation, and the amounts of hydrogen and helium. These 3 pieces of evidence are important because they support the Big Bang. How, you may ask? Well, the expansion of the universe is thanks to galaxies that were redshifted. Some scientists believe that cosmic microwave background radiation is leftover heat from the Big Bang. Lastly, a few other scientists found a large percentage of hydrogen and helium in the universe, which may contribute to the speed it expanded at. So, what have you learned from watching this video? There exist many types of stars in our universe. Some of them fuse light elements, while others fuse heavy elements. Fusion is also related to stars. It helps them, along with the sun, which itself is a star, stay powered and can lead to a supernova. Finally, you should know that stars are a part of our universe, which was created through the Big Bang and involved redshift, cosmic microwave background radiation, and hydrogen and helium to ensure that its process succeeded. Stars in our universe, no matter how different they are, will stay in the skies to fascinate new people and make them wonder how many types there could exist. And that's it for this physics lesson. Bye for now.